Hey, hi everyone. So I'm back with a short video. So today I'm going to take you guys through a very specific shallow neural network. Why I'm saying it's shallow because it's not deep. So that's why it's shallow. However, the very interesting part is that it is a multitasking as well as multivariate deep. No, not deep, it's a shallow neural network. Okay, so I will come to the part where where I said multivariate. Right now let's focus on multitask. So let's go ahead. I have already loaded my libraries and I will go ahead and load the data set here. Let's see the heads of the data set. So I'm using the same insurance claim data set from my first video, and I will go ahead and look into the columns. Let's see what all columns are there. Wow, there are multiple columns. I do not need everything. I'm gonna drop most of them and retain a few of them. So okay, so these are the ones that I'm going to retain. So let me explain. We are going to retain age. We're going to retain policy annual premium. We are also going to retain incident type, collision type, incident severity. Now, here is the catch. These are all independent variables. We have our dependent variables, and as you can see, there are two, because we're going to perform two tasks. One, classification, another or regression. However, we'll be using one shallow neural network. So let's see what are the unique categorical variables available. So here is the one for incident type: multiple vehicle collision, single vehicle, vehicle theft, parked vehicle. So this is called fraudulent report. So that is what I'm going to predict if it's a fraud or it's not a fraud. So binary, and then I see that there are other one as well, which is incident severity, and which have classes like total loss, minor damage, major damage, trivial damage, as well as I see there is another one which is collision type. So the purpose over is very simple. We are going to go ahead and see if there is a claim, and if the claim is a fraudulent claim. Okay, and remember, only one neural network. So let's introduce label binderizers. Label encoders. Yes, you can use label binderizer as well. You can use pd.getDummies. You can go ahead and use ordinal encoding, but I'm going to use label encoding for now. And let's go ahead and use a robust scaler. I'm going to scale the two continuous variables. One is total claim amount, and another one would be annual policy annual premium. Okay, let's see how. Let's pull in the head. Okay, the scaling has been done. The label encoding also has been done. Okay, great. How much data set do we have? Okay, we have around 1,000 data points, not data set, 1,000 data points. And let's see I don't think so we need to see the head once again. We have done the head already. So let's go ahead and delete that head. Okay, I'm going to convert them into values. Okay, now let's do the train and train split. Test and train split has been done. So I'm choosing all these 5 independent variables, and the rest would be my dependent variables. So that's how I'm gonna split into x train, x test, y train. This is a simple now x train, x test split, nothing huge about it. So let's see. Okay, so 800 data points and 200 data points, the same, it has been divided equally. So x train, I just want to see, yes, so we are good with the x train, y train. We are good with the y train, not a problem here. Let's go ahead and now, so if you do not understand what I'm doing with np.transpose, don't bother about it. Let's just move on. Probably I'll make another video about what is np.transpose. So let me see the shape. Okay, good, good. The shape is good. And now let me go ahead and see the lens. Well divided. Now let's talk about the actual model. So what I'm going to do over here, I have three categorical variables and two continuous variables. Again, it's a basic model. I am going ahead and concatenating all of them, as you can see over here. All the list inputs, these are the inputs. I'm concatenating them, and then I'm putting them through a dense layer. Okay, and then I'm do the output. There are two outputs. One is a claim prediction, one is a fraud prediction. Okay, and I'm using a linear and a sigmoid. That completely depends on your data and the neural network architecture. So let's move on. Let's see if we can pass through the modeling, or if the model throws any errors. Okay, what's going on? Okay, I think it has executed. Let's try to do it once again. Yes, pretty much, no error. Okay, so let me print the summary. Great, that's the model summary. Now, this is the main thing. This will give you the architecture. Okay, so here is the architecture. As you can see, we have 5 input variables over here, concatenated, put through a dense layer, 2 predictions. Okay, now I'll let you know where you can go and find a very good documentation. It's called Keras functional API that I have used in my models. So I'm going to go ahead and do the model compile. Okay, I'm using RMSC and a binary cross entropy loss, and here are my training inputs. Let's not go ahead and do the length. No, let's go ahead and do it. Okay, length is 5, I know that. And let me see if they're equal. Okay, or else it will throw an error while I am trying to do a model, model fit. So that's fine. Okay, now let's run with the validation split. I'm going to run only 10 epochs. Okay, so here we go. Great, done. Okay, it's done and dusted. Great. So what we see over here is okay, fraud loss. That's okay. My focus is not how the model is performing, but to show you how can you do multitasking using a single shallow network, single neural network. So over here you see validation claim loss, and it's going down, so it's downwards. Probably the model is, if I run more epochs, it will not overfit. Let's go ahead and evaluate. Okay, I got a 69% accuracy. Not that great, but that's fine. That's fine accuracy, and also you can go ahead and do the RMSE from here. So, what did we learn here? We learned how to use a single neural network to do multiple prediction. Now, let me talk about a little on the multivariate. Now, there are problems with this neural network in a situation where few of your independent variables doesn't have a good relation with the dependent variable. You will not get a good prediction. Now, it is good if I'm able to use a multivariate time series. Let's say I have a multivariate time series and I have one independent variable, and I am trying to predict two dependent variables. So that's where multivariate comes into picture. These kind of neural networks are very handy, and you can very well use it. You can also use multiple independent variables to go ahead and do multiple or multivariate predictions as well. So it's a mix and match. You can also use images, you can also use texts. So this categorical variables can be replaced with text or images, and there are a lot of things that you can play around. Where you can find important information regarding it is the Keras functional API. So let's see, where is the Keras functional API? Let me just go back. I guess I have it. Okay, this is Keras loss. Keras functional API. Let me take, okay, NumPy, okay. Keras functional API. I think it should be here somewhere. Keras API reference, Keras model or API. Okay, here we go. Or let me just type in Keras functional API. Okay, here we go. Easy, just type it in. Google will help you out. Okay, so here is what I have done, almost similar to this. Okay, yeah, this is what Keras has, and this is what I have done. Here we have text. As you can see, they're using LSTMs and embeddings. So as I said, you can use text also and use single neural network, or a single, a multiple neural network also you can use. However, here they're using a single neural network to do the prediction. So that's all about it. And if you guys want to see anything else, please feel free to leave your suggestions under the video when I'm going to post it. So thank you for watching. Bye now.